Hello, good evening. So, welcome to the another section of conics. And in this session, we are going to discuss ellipse. So, let's go for the ellipse. What is ellipse? So, I want the locus of all those points. So, to set off all the points in a plane, set off all the points in a plane whose sum of distances, whose sum of distances from two fixed points is constant. Now, which means, that means if I take 2 points here, say point S, and this is my point S dash, then I'm looking for the locus of this point P, okay, whose sum of distance. That means this is SP, and this is S dash P. This is constant. So I want SP plus S dash P to be constant. So I want the locus of my point P. So it could be this somewhere here. Yeah. So I want the locus of all those points such that SP plus S dash P is equal to constant. Now for the simplicity, what we will take this constant, okay? So let the constant be 2a. We'll get to know the meaning once we derive this. So now, and let two fixed points be on the x-axis. So let two fixed points, let two fixed points be on x-axis, on the x-axis. Say I'm taking this. Suppose this is my x-axis and this is my fixed point here, say S, and this is S dash. So this point I take to be the C comma 0, and this is minus C comma 0, just to maintain the symmetry. And now I'm looking for the locus of my point P, okay, which is X comma Y. And now I want this locus, SP plus S dash P, to be constant, and this constant we have taken to be 2a. So we'll use this notation. That means SP plus S dash P is equal to 2a. We can simply apply the distance formula. So SP is going to give me x minus c square plus y square plus square root of x plus c square plus y square is equal to 2a. Now this is my equation 1. To solve this equation would be a bit solving this equation would be a bit difficult, because we need to square it and then transform some of the terms to that side and then square it again. So it's better we use little algebra. Okay, so if we make use of some algebra, so we know that if I consider x minus c square plus y square, and then minus of x plus c square plus y square is equal to, I'm going to get here, if we consider x minus c square plus y square minus x plus y square, I'm going to get here minus 4cx, because y square and y square ultimately get cancelled. So now what we are going to do is, we have this equation here. So I'm calling this equation to be equation 2. Now what happens? If you see the algebra part, then this is basically root of a plus root of b is equal to 2a written. And this equation is nothing but a minus b is equal to minus 4cx written. So if I write down here a minus b over root of a plus root of b, that means what I'm doing, I'm dividing this equation a minus b by root of a plus b. So I get minus 4cx over 2a. So a minus b over root of a plus b could be written as root of a minus root of b is equal to minus 2cx over a. No. So this a minus b, basically we have written like this, root of a minus root of b into root of a plus root of b. So that this root of a plus root of b part gets cancelled, and I get root of a minus root of b. Now it remains to write down this equation, root of a minus root of b. So I'll be having square root of x minus c square plus y square minus square root of x plus c square plus y square is equal to minus 2 cx over a. That's what I'm getting here, 2cx over a. Now, if you look at the first equation and say we call this equation to be 3. So now these two equations, they look like some simultaneous linear equations. So one of the variable is this, one of them is this. So it's like a plus b is equal to 2a and a minus b is equal to minus 2cx over a. So I'm going to add equations 1 and 3. So adding 1 and 3. So the moment I add first and third equation, I see that this part gets cancelled. And I'm left with 2 times square root of x minus c square plus y square is equal to, this is 2a. So 2a minus 2cx over a. And we can get rid of this 2 also and square this term. So I'm going to get x square minus 2cx plus c square plus y square is equal to a square plus c square x square over a square. Then minus this a and a gets cancelled. I get here 2cx. So I see that 2cx also gets cancelled. Now I'll take the like terms together. So I'm going to have here 1 minus c square over a square. And then I have here x square and plus y square is equal to, this will give me a square minus c square. I can simplify this further and get it a square minus c square the whole upon a square times x square plus y square is equal to a square minus c square. Now I'm going to divide this equation throughout by a square minus c square. So I'm going to get here x square over a square plus y square over a square minus c square is equal to 1. Now I'm going to call this equation just for simplicity. So call b square is equal to a square minus c square. So I'm going to get here x square over a square plus y square over b square is equal to 1. This is nothing but the standard equation of ellipse. Now, so we need, since we have defined this b square is equal to a square minus c square, so what this is? Now, since we have the ellipse here, that means we need to define the eccentricity part. So eccentricity of ellipse we need to have here. So eccentricity of ellipse. So what this eccentricity talks about? So basically it talks about the flatness of the ellipse. So flatness of the ellipse. So for the flatness of the ellipse is nothing but the distance of focus from center over the distance of vertex from center. So the flatness of ellipse is going to be described by the eccentricity. So E is equal to distance of focus from center. So we know the center, if I consider this point here, so the midpoint is going to be the center here. So this distance, this is the fixed point, we are calling it the foci. So these two fixed points are nothing but the foci, S and S dash. So E is going to be basically C over distance of focus from the distance of vertex. Oh, we're going to define this vertex and focus here in detail. So right now we have this E is equal to C over A. So I'm going to consider squaring this. So C square over A square. Now C square we have taken from here. And C square I can write it A square minus B square over A square. So A square minus B square over A square can be written as further 1 minus B square over A square. So we get our standard E square is equal to 1 minus B square over A square. This is nothing but the eccentricity of ellipse. Now this is a positive quantity and here B is less than A. So E is going to lie between 0 and 1. E is going to lie between 0 and 1 for the ellipse. for the ellipse. Now we need to see what these things are. Okay. So far we have written all these things. Now let's go ahead and suppose let's first define all these terminologies basically. Okay. So the line segment through the foci is called as the major axis. Okay, so line segment through the foci is called as the major axis, and that means we're talking about this thing, this one which we have drawn. So this line segment is called as the major axis, and now the line passing through the center of the ellipse and perpendicular to the major axis. So the line passing through the center of ellipse, and perpendicular to the major axis, is called as the minor axis. It's called as the minor axis, and vertex is called as the endpoints of major and minor axis are called as the vertices. Or in some of the reference books, they will define this to be the point of intersection of conic, okay, with the major axis is called as the vertex. So they are also absolutely correct. So the endpoints of major and minor axis is nothing but the vertex. So now we have defined the flatness here. So this was nothing but the distance of vertex from center and distance of focus. The two fixed points at S and S dash. S and S dash are called as the foci, the two fixed points which we have taken in our consideration. Now, let's see the diagram of ellipse here. So that's how an ellipse looks like. So this point right here is the center, which is 0, 0. This is my point S here, and this is S dash. And now we need to see here a lot of things. So let's go ahead. So this point I have here, x square over a square plus y square over b square is equal to 1. So in this case, we have taken b to be less than a. So b is basically the here intercept on the y-axis. That means this line would cut here the x-axis and y-axis, my conic basically. So this point is going to be here a comma 0. And this point right here is going to be my minus a comma 0. And this point is 0 comma b, and this point is 0 comma minus b. So this 2a which we had taken was nothing but the length of major axis. And now we're going to see here what these things are. So point S is basically C comma 0 we had taken there. So C comma 0 we had taken earlier. S is foci. And here I'm going to have here minus C comma 0. So let us see. This is 0 comma 0. C is 0, C comma 0 here we have taken to be S, and this point is the vertex A comma 0. Now we're going to define this thing here. We have taken C to be C square is equal to A square minus B square. From this we had considered C square to be A square minus B square. From here we get, that means I can write down I can take a square common because we want to see C in terms of A and B, because our consideration is A and B. Now C is the role of C is over. So a square I'll take common. So I get here B 1 minus B square over A square. So of course we have defined this to be the eccentricity 1 minus B square over A square. So I get A square here. So definitely I'm going to get C is equal to plus or minus AE. That means I get my coordinates of the focus as, so therefore coordinates of the focus. So coordinates of the focus is going to be plus or minus AE comma 0. So S is going to be here AE comma 0 as per our consideration, and S dash is minus AE comma 0. So we have here A comma 0 and minus A comma 0. We have got the endpoints, coordinates of the focus. Now this right here is going to be the directrix for the ellipse. So the directrix here is x is equal to A over E, and this directrix is x is equal to minus A over E. Now we have two directrices, x is equal to A over E corresponding to this focus, and minus A over E corresponding to this focus. Now, so I'm going to name all of them, and we will have the terminology. Let's go ahead. So this is my point, AE comma 0, the first focus here S, and S dash is minus AE comma 0. This is 0 comma 0 here, and this point right here is A over E. So x is equal to A over is this line, and x is equal to minus A over is this line. 0 comma 0 is the center here, C. We'll take. These are the vertices. We have all of them now. So, of course, now rest of the things we have to write down the terminologies like the directrix, okay, chord, focal chord, length of lattice rectum, all these things we have to describe. So I'm just going to put it here. These are the basic terminologies related to the ellipse, the center, the midpoint of the line segment joining as an S dash. And then we have the directrix, so the fixed line perpendicular to the major axis. Then we have the chord. So chord is basically a line segment joining two distinct points. Joining two distinct points on the ellipse is nothing but the chord. And double ordinate is chord perpendicular to the major axis of ellipse. And lattice rectum is the double ordinate passing through the focus. So now we are going to see here all the things here written. So for the standard equation is x square over a square plus y square over b square is equal to 1. And here we're going to see that a is more than b. A is more than b. So for this thing, we have the center. Center is 0 comma 0. And then we have the vertices plus minus a comma 0 and 0 comma plus minus b here. Some of them call this co-vertices, okay, depends upon them. And then we have here the foci. So foci here is what? Plus or minus a comma 0. And then the directrices. So the directrices are x is equal to a by e and x is equal to minus a by e. These are the two directrices here. And now we're going to see the lattice rectum here. That's also a very important term here. So lattice rectum is nothing but the double ordinate. Double ordinate is basically perpendicular. So if I have a chord here which joins 2 points on the ellipse and it's perpendicular to the major axis, then it's double ordinate. And now if my double ordinate passes through the focus, then it's called as the lattice rectum. Also, this is the focal chord, a special focal chord. So we can see that focal chord perpendicular to the axis, major axis, is nothing but the lattice rectum. So we're now going to see the end points of lattice rectum. So end points of lattice rectum, we can now get it. So end points of lattice rectum. Now this we need to calculate because here x is going to be a comma. This point we need to find out. So what is this point? So a comma this one here, and then also we have minus a. So we will see what do we get here because y is definitely going to be fixed here. So I'm going to have here two lattice rectum, but since this is plural, so we call it latera recta. Now let's find out. So x square over a square plus y square over b square is equal to 1. Now this point a comma 0 lies on the ellipse. That means I'm going to have here a square e square over a square plus y square over b square is equal to 1. So this gets cancelled. So I have here basically y square over b square is equal to 1 minus e square. So if we see the relationship between eccentricity, then eccentricity here is E square is equal to 1 minus B square over A square. This is the relationship between A, B, and E for this ellipse, for A more than B. So 1 minus E square now I can replace by B square minus A square. So from here I get to see that Y square is equal to B power 4 over A square. So Y coordinate is going to be B square plus or minus over A. So this point right here is going to be B square over A, and this is going to be minus B square over A. So B square over A and A comma minus B square over A. Also we have for this point, we have minus A comma B square by A and minus A comma minus B square over A. So these are my endpoints of the lattice rectum. And then we get the length of lattice rectum. So length of lattice rectum is this distance, which is B square over A, and similarly B square over here. So that means we can just add these two, and I get here 2 times B square over A. So these are the endpoints of the lattice rectum here. Now, so once we have got this thing, now these are the basic terminologies and basic terms related to the standard ellipse. So standard ellipse means we consider the major axis to be x-axis here, and also we need to find out the major axis. So major axis will be here, x-axis right here, and length of major axis is 2a. So the length of major axis is 2a. That means from this vertex to this vertex. That's the major axis. That means major portion of the ellipse is lying on which axis? That is called as the major axis. And length of minor axis and length of minor axis is 2b. The length of major axis and minor axis is also 2a and 2b respectively. Now, one obvious question would be, we have seen this ellipse to be what here? A is more than B. Okay, that means major portion is on the x-axis. Entire thing that we have done is for A more than B. So the obvious question will be, what will happen if A is less than B? Okay, so we have another form of ellipse. Okay, so we have another ellipse basically, where what happens? My B is more than A. Okay, that is, the major axis now becomes y-axis. Major axis now becomes the y-axis. What kind of ellipse we are going to have? Let's see. The ellipse would be looking like this. And now this is my x-axis here, and this is going to be the y-axis. So here also everything remains same. Okay, except the coordinates. Coordinates would change, of course, because you see here the major portion is lying on the x-axis. So y-axis. So this is my B point here. So 0 comma B is here, and 0 comma minus B is here. This is my point 0 comma 0. So the foci here is going to be 0 comma BE, and this is going to be 0 comma minus BE. So we have the foci, and directrix corresponding to this would be y is equal to B by E, and here this is y is equal to minus B by E for this. Now we need to find the lattice rectum and all, so let's go ahead and find it. So here for this ellipse, the major equation remains same. Okay, equation remains same as the standard equation. So the equation is x square over a square plus y square over b square is equal to 1. Only thing is that here a is less than b. Okay, it's a b is more than a. That means major portion is lying on the y-axis. And of course, center here is still 0 comma 0. Center is 0 comma 0. So the vertex becomes now 0 comma plus or minus b. And now this time this becomes the co-vertex. So plus or minus a comma 0. And then we have the foci here. So foci is 0 comma plus or minus b e. And then directrices. So the directrices are going to be y is equal to plus or minus b over e. This is going to be the directrix. Now, directrices I have y is equal to plus or minus b over e. Then the next point is the end points of lattice rectum. So end points of lattice rectum. And also for this thing, the relationship between A, B, and E is very important. So the relationship for them is going to be, we just need to interchange a and b. So I'm going to have a e square is equal to a square minus b square here this time. So a square over b square. Earlier it was b square minus a square for these ellipses. B square minus a square. Now it's going to be reversed. That means I'm going to have here a square over b square. So endpoints of lattice rectum we need to find out. So I just need these 4 points, this one, and this, and these 4 points I need. So let's get them. I know my y coordinate is b comma e. So b comma e is lying on the ellipse. So b comma e is lying on the ellipse. That means I can get it here. So x square over a square plus y square over b square is equal to 1. Now since y is equal to b is lying on the line, lying on the ellipse, y is equal to be is on the ellipse. So this line y is equal to be is on the ellipse. So I can plug in here. So I get x square over a square plus y is what? Be square over b square is equal to 1. So from here, this b square gets cancelled and I get x square over a square is equal to 1 minus e square. So x square a square will be equal to 1 minus e square. I can get it from here, which is a square over b square. So I get a square over b square, which means x square is equal to a power 4 over b square. So this implies x is equal to plus or minus a square over b square. So we get the endpoints to be, so endpoints of lattice rectum is going to be plus or minus, this is not b square, just b, because b is not being squared here. It's simply b square. This is a power 4, so a square. This is going to be a square over b, comma, this is going to be be here, and for this one I'm going to have same thing. This is going to be minus b, and this point remains same again. So plus or minus a square over b. So we get our endpoints of lattice rectum. So this point is a square over b, comma, be, and minus a square over b, comma, b. And also for this one, we get a square over b, comma, minus be, and minus a square b, comma, minus be. So from here we get the length of lattice rectum also. So length of lattice rectum we can describe here. So length of lattice rectum is going to be this. From here to here we have to measure. So we know this point and this point. One can use distance formula or one can use common sense. So it's best to use common sense, because from here to here this is simply a square over b. So I get 2a square b. So 2a square over b is nothing but my length of lattice rectum for this ellipse. So this is all about the terminologies here and about the standard ellipse. Okay, the 2 types of ellipse that we have seen. Now we will move to the focus directrix property here. Okay, the most important part of the conic here. So recall the focus directrix property. So the focus directrix property. The focus directrix property is the same thing. That means I'm looking for the ratio of distances from, this is my fixed point S, say alpha comma beta, and I have a fixed line, say Lx plus my plus n is equal to 0. So I want distance of this point P from this fixed point and this fixed line. So say I'm saying PM. So this distance we know SP over PM is equal to eccentricity E. So that means from here I'm going to get SP. So P is, we can consider to be H comma K, because we need the locus. So one can start this way. That means I'm going to have here H minus alpha square plus K minus beta square is equal to eccentricity times PM. PM is going to be LH plus MK plus N over square root of L square plus N square. Now, after simplifying, upon simplification, we get ax square plus this ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0. The general equation of conic we get here. The general equation of conic. Now from here we have to be sure, okay, that this is, let's say I'm calling this equation to be my star equation. So star equation represents an ellipse. So star equation represents an ellipse if the first thing is the determinant. Okay, this determinant should not be 0. This determinant should not be 0. And second part is my h square minus ab should be negative. H square is equal to AB was for parabola, and here H square minus AB should be negative. And the third part is that my eccentricity should be between 0 and 1 strictly. Moving further. So considering some basic questions for the things which we have discussed before moving ahead. So when you're solving the ellipse problem, okay, let's say you have to assume any ellipse and then solve. So always assume the standard ellipse where A is more than B. Or you can even assume B more than A, but then accordingly you apply all the formulae. And after getting everything, you would come to know where A is more than B or A is less than B. That won't make the difference in the question. So let the length of a lattice rectum of an ellipse be 10. So length of lattice rectum is 2 if I consider this ellipse. So 2b square over A is equal to 10. So from here I get B square is equal to 5A. So let's keep this one here. And now if its eccentricity is the minimum value of this function, so you have f of t is equal to t square plus t plus 11 by 12. So we want the minimum value of this function, so we can adjust it to the perfect square. So t square plus t plus this is going to be 1 over 4 and then minus 1 over 4 plus 11 over 12. So this is going to be t plus 1 over 2 the whole square. And this one I can multiply here by 3 and here by 3. So 11 minus 3 will be 8 over 12. 4, 2 and then 3. So 2 over 3 is the minimum for this. So 2 over 3 is the minimum. We have found the value. So minimum of f of t is equal to 2 over 3. That means we got the eccentricity of the ellipse. So E is equal to 2 over 3. Because they have given eccentricity is the minimum value of this function. So E is 2 over 3. So that means E square is equal to 1 minus B square over A square. So from here, E square is going to be 4 over 9 is equal to 1 minus B square. We know it's going to be 5A here. So 5A over A square. Now I can solve this equation to get the value of A. Once I got A, I'm going to get B using the same relation. So 4 over 9 is equal to 1 minus 5A over A square. Let's take this here. Hmm. 5. In fact, this gets cancelled here. So I get 5 over A is equal to 1 minus 4 over 9. So this gives me A is equal to 9 itself. Because 9 minus 1, 9 minus 4 is 5 over 9. So A is equal to 9 I get. And now E square is equal to 1 minus B square over A square. I can use this, or else wait a moment. I think using this equation would be better. See, A is equal to 9 we already have got. A is 9. So I know my B square is equal to, A is 9. So here B square is equal to 5 times A. So B square is equal to 5A. So from here I get B square is equal to 45. So now what do we need? We need A square plus B square. So therefore, A square plus B square would be, A square is 20, A square is 81 plus 45. It's going to be 81 plus 45 will give me 6 and then 12. So this turns out to be 126. Moving to the next question. And now we want the length of lattice rectangle of the ellipse whose foci are 2, 5 and 2, minus 3. So if you look at this ellipse here, okay, any of the ellipse you can consider. So if I take the distance between the two foci, then distance between two foci is always taken to be 2AE. So I know the distance between two foci, it's going to be 2AE. So distance between the foci. One can consider the other ellipse also and solve with 2BE and you arrive at the same result. So distance between the two foci is 2AE. So from here, eccentricity is given to be 4 by 5. So distance between two foci is given to be, this is 2, 5 and this is 2, minus 3. So distance is 8. 8 is equal to 2A and E is 4 over 5. So from here, I get A is equal to 5. So once we got A is equal to 5, now what do we need? Eccentricity is going to be 4 by 5. So E square is equal to 1 minus B square over A square. So we can even write down A square E square is equal to A square minus B square. Now A square is 5 and A square is 4 over 5 square, which means 16 is equal to 25 minus B square. So B square is equal to 9. So length of lattice rectum is basically 2B square over A. So 2 times B square is 9 over A is 5. So this gives me 18 over 5. Now coming to the next question. So here we have the length of major axis of an ellipse is equal to 1/4 of distance between the foci. Then we want the eccentricity of ellipse. So length of the minor axis, say 2B. That means length of minor axis is basically for our ellipse. Okay, we always consider the standard ellipse for solving. So we can consider the standard ellipse to be on the x-axis and then solve the problem. So length of minor axis is say 2B is equal to 1/4 of distance between the foci, means 2AE. So we want the eccentricity of ellipse. So this relation we have. So from here we get this 2 getting cancelled and then 4B is equal to AE. So this we have. Now we know eccentricity of ellipse is what? E square is equal to 1 minus B square over A square. So and here we can get it A square E square is equal to A square minus B square. So A square E square, I'm going to have it here. So A square E square will be 16B square. So we can plug in here. So 16B square is equal to A square minus B square, means I get 17B square is equal to A square. Now we need to get the eccentricity. So there is no information available, no problem. So I can just plug in now this one here because anyway we want the eccentricity. So E square is equal to 1 minus B square and A square is 17B square. So I can write down here 17B square. So this B square and B square gets cancelled. So E square is basically 17 minus 1, 16 by 17. So E is equal to 4 over root 17. This gives me the eccentricity. So that's all for today, and we'll see you again in the next session. We will come with tangency, position of point, and the remaining things. Okay, this is all just about the very basic of the first session of the ellipse. Thank you so much. See you.